Answers to the quiz. 36. You should have had A, I think.
What?
A.
Wait, what about? Isn't it asking about flux though?
Let me read all the answers and I'll happily talk about it. It is asking about flux, absolutely. 38. D. 40. I got A.
I got A.
I'm not sure I understood the problem, but I think it's A. 468 is E. And then the free response, you should have had 1, 2, 3. You should have like twice as many arrows coming out from the inside ball and striking the outside circle. Then you should have half as many of those arrows continuing on.
Yeah. Let's go.
Okay, and then B, you should have E electric field is equal to Q over E naught 2 pi r squared.
Yeah.
C should have been Q over 3 E naught pi r. Oh, not sounding like a firm answer there.
Q over 3.
I got Q over 3 E naught pi r. And then D, what would be the final distribution of charge? The spheres were joined by a conducting wire. There would be plus Q on the outside shell only.
Right.
The outside of the outside shell only, because the farthest they can get away from each other. All right, the charge will continue to move until it gets as far away as it possibly can. So it says you just basically turn into one big superconductor. The outside gets all the plus Q charge. All right, what problem's that now? Let's go back to the one you were talking about. First one, closed surface. Closed surface means it's a three-dimensional shape, right? Filled in all the way. Okay, good. It's permeated by electric field as shown below. The sum of the scalar products of E with each differential element of A is. So we're talking about flux. That's correct. So if the surface is closed, that means whatever strikes the bottom also comes out the top, right? So the net flux would be 0. So the only way to have the charge be other than 0 would be what?
If they have a charge inside.
If you have a charge inside. If you have a charge inside, then it would not be 0. The electric field is certainly not causing it. Now, I must admit, E feels good to me. I'm not. This is one of your jerky questions where you're like, A is a better answer than E. I don't like those on a physics test. It should always be the right answer, and this is not one of those. My further question said there's no charges floating around inside the surface. Then they asked the question, and E would be the correct answer. Yes, sir.
Can you do 38?
38. Let's do 38. 38 is a solid conducting sphere. Solid conducting sphere. That means I've got a sphere that is completely filled in with metal, right? So I want to know what the electric field is if I start here and move my way outwards.
Oh, that's what it sounds.
Right? Doesn't it? Where my radius is that. So this radius is A.
Yeah.
So there is no charge. All the charge is going to be on the outside, right? So you're going to have a 0, 0, 0, 0. When you get to A, it's going to shoot up. Yeah. And then it's going to go.
I didn't read the conductor part.
Oh. Now, if it was a semiconductor, it was a non-conductor, and it was completely uniformly distributed, then you're right. It would be like this, and hopefully that would be answer.
That's what
I'm not even sure that's A. It has to be a straight line.
Oh,
they bent that line. So it would not even be A. It would be none of the above.
Is there any, like, mathematical?
Yes. Gauss's law.
What was that, like, integral?
Yeah. Integral E dot dA is equal to Q enclosed over E naught. We know, therefore, EA equals Q enclosed over E naught. Now, for a conductor, all the charge is going to be outside. So how much charge is enclosed when I draw a shape on the inside? 0. There's no charge enclosed, so the electric field has to be 0. So my electric field is going to be 0 because I have no charge enclosed, no charge enclosed, no charge enclosed, no charge enclosed, no charge enclosed. So I get just outside of that layer. Then what happens? Boom, I have whatever the electric field is right at the surface. Then after that, it goes as r squared, right? Because I'm going to use 4 pi r squared, right? So when I move it to the other side, I get Q enclosed over 4 pi r squared to the bottom, which means we're going to have a parabola which is getting closer and closer to 0 electric field, getting closer and closer to where? Infinity. Good.
Why isn't it 8?
Yeah, it's
Isn't that
because
like half of it.
it has 0 electric field all the way until it gets to the surface. It's conductor. There's no charge floating on the inside of the conductor.
Oh yeah.
None. So it has to be nothing, 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 boom, up to A. Now what we're discussing is, and it's a cute little trick they often ask, is if this was a uniformly charged non-conductor, so there's a bunch of random charges floating around the inside, right?
Mm-hmm.
Then what would happen actually is, if you do the math carefully, you get, it goes as a line, increasing until it gets to the surface, and then and this also applies to gravitational field like on the Earth. Like you're starting at the center of the Earth and working your way up, you're like the force on you looks like just like this graph. It goes as a line until you get to the surface. When you get to the surface, it starts tailing off the R squared because that's the normal equation. Okay? All right. Dealage. Other questions? 68? Okay. All right, 68. I have a circle with a radius r, coordinate diagram. I know you would have got so far. A little r here and an e here. Is that right? Okay, conducting sphere, so all the charge on the surface. A radius r carries a charge q at the distance r from the surface of the sphere. Electric field is most closely proportional to. All right, so I go integral e dot dA equals q enclosed or e naught. Actually, it's a multiple choice, so I don't bother even writing that down because I know it's going to be this in just a second. Unless I get confused, then I might back up and look at it again. Okay, electric field is what I'm looking for. It's a sphere. I'm going to draw a sphere around it, right? I'm going to draw a sphere all the way around it. So the sphere is going to be 4 pi r squared, agreed? Q enclosed over E naught. But this r is the distance from, is the radius of the sphere I'm drawing, right?
Yeah.
So the r is going to be E equals Q enclosed over E naught times that r, 4 pi, times that r, which is going to be big R plus little r squared.
When do you not use the sum of them?
The sum of them?
Like the sum of the radius. Like when you just use the outside radius.
Well, oftentimes when they do the problems, they just tell you you're this far from the center. Right, and so you use that radius. You're not going to use this radius ever that I can think of.
Okay.
Right, it has to be linked to the other one. Right, because it's the shape you're drawing that determines this R here. The shape I'm drawing is a radius all the way to the center of the thing I'm drawing. That's always true even for cylinders or whatever.
Okay.
There you go. All right, other problems?
Can you go over D on the free response?
D free response.
I have no idea what
Ugh.
Can we just do the whole free response?
Oh, let's do the whole free response. Let me start off full free response. Okay, so first of all, it says the diagram line, draw like the field lines inside. Oh, like the field line. That's the last chapter, not this one. What a jerk. He's giving us problems in the last chapter. I'm not ready for that. Didn't study that part. Okay, so we know this is plus 2q. We know this is negative q, agreed? All right, which means, yes. So,
Can I get my earbuds?
oh, dude, nutrition.
Sorry, I forgot.
Teaching a class.
My bad. Thank
You
you.
don't need it for class, do you?
Yeah.
No, you don't.
I want to listen to music.
During class?
I'm about to.
You are?
Yes.
What's wrong with that teacher? Oh, check what class he's in. He's probably sitting on the mats. OOP, where they sit down. I shouldn't record that out loud. Okay, let's go on. All right, so plus 2q. So I noticed this has got minus 4q, so I have to have 4 arrows going into it. How do I get 4 arrows going into it? I get a little confused, so I'm going to make 8 arrows leaving this one and try to figure out what's going on. Whoop, 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 whoop. Now I need to at 4. I need to hit the outside. That's problematic. Why? Because there's no way 8 aren't hitting it.
Yeah.
So I got a problem on my hands. I got to get rid of 4 arrows somehow. How do I do that? Despite the fact the outside is negative, I draw some arrows leaving it. Got no option there.
The positive charge is like 30 newtons.
The truth of the matter, what's really happening is in that outside shell, electrons are sinking down to the middle. And so you actually have a plus 2Q, a minus 2Q on the inside of that shell, and you have a plus 1Q on the outside.
Why can't we write it?
Why can't you write like what?
Why don't we just like say that?
Because they expect you to do it yourself because you're a physics student. They want you to know. Want to know if you know that that's true. It's ridiculous what they expect of you children. All right, B. B. Gauss's law. Find the expression for the magnitude of the electric field between the two. Between the two. So I'm going to draw my Gaussian shape. It's going to be a sphere in the middle. Because of free response, I'm going to bother to write this down, just the off chance this is one of my 2 points, and I don't want to lose that point. That'd be lame. But I immediately realized I'm just going to use this formula because I'm going to draw a shape that can be trusted to completely surround it and is symmetric, so that it feels the same on every spot. Yeah? I'm trusted now to do that. So I want to find the electric field. The shape I drew is a sphere, so it's going to have 4 pi r squared surface area. Q enclosed. Now I've only enclosed the middle sphere, right? So I got 2Q for that over E naught. I did not enclose the outside at all. That's not my problem.
Like even if like
If whatever's enclosed, whatever's inside of your sphere you drew is all that matters. Okay. As long as it's symmetric. It's a big as long as. But okay, and then moving to the other side, I get E equals, I got 2Q, so 2, Q is 2Q, or I did that, 2Q, over 4 pi, R is capital R, squared E naught. So hopefully that's the answer I read. Except the 2's cancel out. Oh, it's lowercase r, sorry, lowercase r, thank you. Yep.
If it ever asks just like potential difference and not the electric field, should we just like retake like the double integral of that?
You could. Okay. I like the stopping on the way myself, but you don't have to. So then I'm going to integrate this formula. I got Q, I got 2 pi, I've got an r squared, and I've got an E naught. I'm going to move the r squared to make it r to the negative 2. Is that okay with you?
Yep.
And I want to know the distance between the 2 spheres, so I'm going to say I'm going to start at r, and I'm going to go to 3r. It doesn't say which way I'm going, so the sign isn't going to matter. So I'm just going to go ahead and do the integral here, right? So raise this power by 1, divide by the power I get. I've got a negative floating out here that you can actually keep or leave. You can do either one, I think. Is that right? Oh, I have to put my 3r and my r in here. Okay. Now again, these could be in reverse order because it doesn't say which one from where to where. You're supposed to say from where to where. It just says the difference between the two. Okay. So A could be a positive negative answer, what they're telling me. So I'm going to put in the 3r, negative q over 2 pi 3r, minus a negative q over 2 pi r. Oh, this is 3r. All right. So then I note that I've got a fraction situation here, which essentially this is 1/6 of a q over pi r. This is 1/2 of a q over pi r. And this is negative, so I do a negative minus a positive, I end up with 2/3. I didn't get the 2/3, that's weird. 3 E naught pi r. Let me check my math because I'm not sure I'm going to run the boat here. I dropped my 2. What a jerk. Okay, so I think I'm right now. Nope, yep. No, it can't be 2/3, it's 1/3. Half minus 6. What am I doing? Drinking. No drinking. Good? All right. Flipping it over. I'm going to pause this fast here. Pausing.